Welcome to .NET Conf 2025. Today I'm going to talk to you about nullable reference types and why I think they're important. I'm Shawn Wildermuth. I'm a Microsoft MVP, an author, instructor, and a consultant. You might have seen me on my YouTube channel, or maybe through my Pluralsight courses, or a bunch of the conferences I've done. Thanks for being here. So I get a lot of people asking me why C# continues to change. And for me, it's an important question because a lot of the new features that are coming in are trying to make C# better, but it does cause some older C# users, people who have been using it for a long time, to get a little nervous and trying to keep up with the latest thing. One of the things that was added in recent versions was nullable reference types. But I think this is a really good thing, even though for users of it, or especially with older code bases, you might be a little intimidated by it because it's going to change the way you have to write code. So what are nullable reference types? I think these are actually misnamed. I know all the Microsoft folks that are listening to me now are going to get a little annoyed, but it really is, non-nullable references. So since the beginning of time, we had value types and reference types, and value types couldn't be null initially, though I'm going to show you how they support null as well. And references were always nullable. They were always references to some point in memory that could be null. A nullable reference type says that reference types can be defined as not null for the first time. This really helps us have a clearer understanding of null, and it gives us a similar functionality to nullability of value types, which is something a lot of people have used since I think version 2 of C#. The compiler tries to help so that you don't have to use the same syntax over and over and over again, and I'll show you how that works. And using some of the operators becomes critical, and I'll walk you through a lot of those operators. So let's dig into some code. I'm in Visual Studio Code, though this would be the same in Visual Studio as well. I have been using the latest version, but I think it's a little clearer here where there's not a lot of moving pieces. And so this is a typical project. I'm not using top-level statements. You'll understand why in a moment. But we have this main, which is just where our code is starting, and we can have a var x equals 10, right? And we can both agree that this is going to be an integer. This integer is going to be a value type. It can only refer to that value. And then we can also say name equals Shawn. And this is going to imply that name is going to be a string. Now, one of the curiosities here is you'll see that it's defining it as a string question mark. This is one of those operators. The question mark defines something as nullable, but this is only true because we're using the latest version of .NET. Let's open up that CS project file and talk about this. So we can see that nullable enable is turned on here. Let's go back to the old way of doing this before nullable reference type, so we can see how this kind of works. Now when we look at that name, it is simply a string, and we can simply say, you know what, we now want that string to be null, or we can't say this value type can be null, right? They are under different semantics. And let's just make sure that this is clear without using the string, though I want you to see that if you have nullable references turned on, you're going to get a different behavior here. But here, this is perfectly fine. No one's complaining. The only complaint here is that we haven't used it yet. And so actually, let's come down here and just call show value x and show value name, right? Show value is just writing it out with a value and what the value is. And if we run this, we can see that first it's not going to compile because this can't be null. So let's kick that out for a minute. Let's run it again. And here you can see we're getting that value of 10, and null is just gone, right? There's nothing there. When we try to concatenate these values, null becomes nothing, right? Because it's null. That should be pretty clear. What's interesting is this idea of nullability goes back a really long way. And so if we come back to here, one of the things a lot of people don't know is for a language version, we can actually say 2.0, right? We're on 14 right now. 2 is perfectly fine. And you'll start to see some different things happen here. This isn't available in C# 2. Please use 3 or greater, because we're starting to use some features in here that aren't working in it. But what 2 did allow us to do, let's make that an int so it's valid code, did allow us to use nullable. So this is effectively saying that this x value now is nullable. We haven't turned nullable reference types because this is a value type. And because it's nullable, this is perfectly fine. So if we run this again, we'll get 2 blanks, right? Because neither of them, both of them are nullable. This nullable wrapper around here is actually just a shortcut. It is a long version of int question mark. And so the idea of being able to take a value type and support null goes back again to C# 2. We've had this idea for a long time. So if we come back here and go ahead and say latest, or preview if you're working with early bits, though we're close enough to the release that latest is giving us 14, we can see that all of this now works in the exact same way we want it to. This question mark still doesn't work because it's not about the latest version, it's about enabling nullable. But let's say we have some old code here and we want to have the new behavior because we're writing some code. We can actually say nullable as a pound declaration to enable and nullable disable. You can actually turn this on and off in existing code. So you don't have to turn this on for an entire project, especially if you have some old code sitting around. You're going to see that you can use this pretty much anywhere you would normally use any C# code, as long as it's working with, I think it's C# 10 or 11 and greater. I believe it's 10. You can enable and disable it. I'm going to turn that off and turn it on for our whole project. And the reason I'm doing this is I'm going to go ahead and enable nullable, which is the thing that turns on nullability. And so all of this code now works because we're able to say, hey, this is a string, I want to do something with it. And remember, down here, we're getting complaints because this value doesn't expect anything to be null, right? This doesn't have a question mark on it. So it expects that the object that's being sent in this case, an integer and a string, are going to be not null. Now this will continue to work. Right? But of course, the problem is that we're getting a warning here because it's not being explicit. This should be a warning when we build it, which if you're like me and are turning warnings into errors, will be an error you need to fix. So instead of that, we can now say object value, and it'll do the right thing, but I don't like that these are blank, right? And so one of the first things you're going to get used to is how to deal with nullability. There's some new operators. Now, the first one I'm going to show you is double question mark. And that basically says, if this is not null, use this value. But if it is, default to, and I'm going to say null. So when we pass in a null here, we're going to get the string quote here because this value is not null. If we hover over it, actually, not if you hover over it. I always forget that doesn't work the way I want. Let's make sure that's saved and run it one more time. And you can see that the values are now null, right? But there's a more interesting problem here, right? So if we get rid of setting my name to null for now, and we come down here, what if I want to get the length of my string, of my name, right? That would ordinarily work, and it's not complaining because the compiler goes, I know that this is a nullable, but I can see you're setting it here. I can figure it out in this scope. This won't always be true, especially when you're passing in variables, but I'll show you how that works in a moment. Name length should have the length here, and what happens if it is null? So let's take it there. The name, that length says this could be a null reference. This is possibly. And so what they want you to do is actually use a question mark after it. And this is saying basically much like the double question mark. This is saying only call this length if it's not null. Otherwise, this len will also be null, right? So when we look at the length here, it's going to be an int question mark. That's how it's inferred, because this could either return the length or a null if this is null as well. And you can use them together with a double question mark to say, make sure it's 0. In this case, we'll always have a number here, and it's no longer an int question mark, it's an int. And so that's one of the sort of magic pieces here of how you want to use simple objects with nullability. Because what did this look like before? This used to look like if name is null, length equals name.length. Actually, if it's is not null, name is length, length equals 0, right? We could have just created this as a 0, and this is what we would have to do in a lot of cases. And if you follow the style guide, I don't really like single line, especially if else's. But we start looking at all this code to do this very simple idea, right? We're just making sure it's not null and doing something about it. Now, what's interesting is, what if we take something like this string or any object that could be null? I'm going to comment this out and do this again, name question mark dot length, and make it 0 if it's not a 0, because I want length to always be in there. What if we want to create a function like we have down here? If we never want this to be nullable, we want to be able to specify that. And so part of the contract is whether there's nullability or not. Because before this, let's disable nullability for a minute. Is this object would be fine, but this object could be null if we're not using nullable reference type. So ordinarily we would do something like argument null exception, throw if null, or throw if null empty. I'm going to say throw if null. Can't be null. Right? The idea here, let me bring it up closer to the top, is that we used to need to check this. Hey, this may be handed us in as null because every object in when we're not using nullable reference types can be null. They all have that ability. There's no way for us to decide that nullability is part of the contract I have with the users of this function or class or whatever it may be. So this warning is telling us that we really should be doing something like that in order to satisfy this function. And so this is one of the key places where I think it's important for us to be using nullable in our projects. I know it can cause a lot of consternation, but this means that the contracts we create for functions or classes or any of that are going to include null as part of that contract, which we haven't been able to do before nullable reference types. What does that mean? That means if we forget a line like this, we're going to be throwing exceptions because something's null and we don't expect it. Instead, we can go, you know what? No one should be able to call us if this object is null. This value has to be a non-null thing. And I've written so much code in the past to check each of the parameters and how they work and all of that. It's just very disconcerting, to be perfectly honest with you. So I really like this because we can really define it in the way we want. So let's talk about classes for a minute. So I'm going to create a class called a user. And let's do what we often do, which is let's create a couple properties. I'm going to create a string for name, get set, right? Same old thing. But with nullable turned on, we're going to start to get these warnings because we're saying this user instance can't have a name that is null, right? We haven't defined this. Of course, we could name it with a question mark, but then we're going to have to deal with whether that's null the entire time. We could define a default, and that would make the error go away as well, and that's sometimes useful. Another way you can do it is to say required. Actually, before we talk about required, we could also create a constructor, right? Here's my user string name equals name, right? That would satisfy this because we're setting the name within the constructor. But what if we don't want to actually support that? Force us to set it, because that does close down some instances when we want to use this. And here we can say required. Now, what does required do? It makes the error go away, but what does that actually do? Let's come down here or up here, and let's create a new user, right? We're immediately going to get an error because username must be set in the object initializer or attribute constructor. So this is allowing us to define in the contract for our class that we have to specify the name for this user. Now, this doesn't require us to have a construction here, but a constructor here, which we could solve it by that. But there are cases where you're going to want this to be the case, because this is also going to be the case when serialization, let's say you're writing APIs and you're using JSON serialization to fill up this object, and normally you would want an empty constructor. Required is going to make that fail if the name is never set, right? Or if it's attempted to set at null, right? Remember, this name isn't nullable, and so we know it has to have a valid use here. And so the idea is we're extending what we can do with a contract by injecting the idea of whether something can be null. Now, what's interesting here is the int isn't specified anywhere, but it's fine. And that's because value types have default values. And in fact, reference types have always had default values, and that default value is null. And because of that, you're going to want to really think about what can be set, of course, because this is non-nullable and this is non-nullable, but what happens is this effectively is doing that, right? Because the default for an int is 0. But we can't do that here because the default of null doesn't work because we have nullability. But it does tell the user of this class exactly what they need to be doing, if that makes sense. So we could put a question mark here to allow it to be null. We could use required here as well. Just because it's a value type doesn't mean it can't be required. But I'm going to leave it empty for now because that's most of what you need to know. Now, this continues this idea. I'm going to create a new, actually, I'm not going to create a new one. I'm going to extend this, what if I'm using generics, right? I put a T in there, and I'm going to call this name type, right? I could just leave T, but this would be a little clearer. And so when I create an instance of this, I can have this name type be here. So let's take our user here, and I'm just going to say string, right? That would be no difference, but we might have a reason to want that T name to be something else. And what happens here is string question mark is perfectly valid, right? Because the T is just saying any type, and this string with a question mark is a nullable nullable string, right? So how do we protect against that? This is another place where I think it's very useful for us to think about this, is that we can actually use not null, right? We can put a constraint on our type to say this cannot be null. So more importantly, cannot be nullable. Putting a question mark here causes an error because now it doesn't match the nullability of the generic type anymore. And so we're looking at this in a pretty grand way. We're looking at it across the ecosystem of the different things we want to care about. When you turn this on, you're going to get a lot of cases where if you specified something like string, it's going to assume it's a non-nullable, and as soon as you try to do something special with it, you're going to get a complaint, and effectively having to go through and do a lot of doing a lot of this, putting in a question mark and such. But what if, coming down here, I try to say user.name equals Bob. Now this isn't going to complain because the compiler is seeing that we defined user. Even though the type is nullable, the type, not the name, but the type is nullable, you're going to see that all of the vars, especially because of backward compatibility, are going to create nullable versions of that. And so the trick there is, if you want it to be not nullable, is to choose the reverse. If you haven't seen this, but this is just the same amount of characters, but it defines what you actually want. Now this isn't complaining at all, right? But what if I came down here and let's go ahead and make a method that says void show name. Nice and simple, right? Because this is just taking a, what doesn't like about the, oh, it's just unused. Yeah. So if I come up here and I go show name, oh yeah, it needs to be public or static. And use our user.bill, it's going to be fine with it as well. Let's make one more chain so we can see what this is actually going to look like. Because this is what your code, when you turn on Nullable, is going to primarily look like. And we're going to just pass in our user. And I'm going to say sometimes people might pass us a nullable username. Oh, of course we need the string here because I made that a type. Because this is not null, this is the thing you're going to see a lot. You're going to go, you know what? Question mark, it'll write out an empty. Maybe that's what I want. But there's also an exclamation point. Exclamation point is you telling the compiler, and this is especially true as you get sort of deeply nested hierarchies, that you know better. You know what? I know this user is never going to be null, even though it's capable of being null. Go ahead and do this. But if the user is null, it's going to throw a null exception. That's all it's doing, is you're saying, I know better. You don't need to deal with the question mark or put in what the default value if it's null. None of that. You're just saying, hey, you know what? I'm never going to pass this. Why it's this? That's a good question, but it does work in that way. One of the other things you'll see, this is actually new to C# 14, so it's new in the new bits, or if you go to the preview or latest version of C#, you're going to see name equals Sally, right? Well, this might not work. This is going to complain because it might be a null reference. So this is where we have had to until recently say if user is null, is not null, user.name equals Sally. And put your is and nots in the right order. But new in 14, we can now just say user (name) equals Sally. And these are equivalent. This says I'm going to set the name Sally if I can, if the user is not null. Right? So this may never get set to Sally if the user is null here. And of course, if you don't want to deal with any of that, make sure that your methods here are returning or specifying inputs that are not nullable. Again, part of that contract. Let's go back to the slides because I know we're running a little bit late. Should always have your Slack notifications turned off by now. So the big question I get with the users that I show this to is, should I be enabling it? My code is fine without it. I know some of you may be thinking, you had a long project, it's never really failed. But is it? What I find is in large code bases that having the idea of whether something could be null can take out a lot of boilerplate, or in many code bases, you could be running into very rare exceptions where that null inside of a reference type that should never be null is causing you grief. It's causing errors in your running systems. You're having to chase down peculiar bugs. And if you make this change, it's going to make your intention explicit. I expect this reference type, this class, this record, whatever it is, to never be null. This means there's less boilerplate for checking for nulls, and that we're using the same facility for value types and reference types. In a sense, the code can be smaller and clearer when you read it because this nullability becomes part of the documentation of what you expect. You can opt into it, as I showed you with the nullable declaration, for parts of your code base as you're starting a project instead of turning it on entirely. Probably a good idea as you're migrating your code bases. And you should do it because all the cool kids are doing it. Well, that's actually not a good reason for any technology. But hopefully some of these others can encourage you to at least try it. Questions?